Okay, so Mr. Kleiber has given you a sequence chain, and let's give a title to this because we are summarizing what we have learned the last couple of days, which is the substitution method. Just like you have a substitute today, and this is the substitution method. Get it? I knew you would. Okay, so first of all, we are given a problem. We are given 3n plus 5m equals 7 and m minus 4n equals 6. Our first step will be to isolate one of the variables. Now, it doesn't matter which one. Isolate the variable. It doesn't matter which one you choose, but you want to pick one that's kind of easy, right? So when I look at these two equations, I can look at the n here or the m here or the n. Well, my winner is going to be that m. So let's get it by itself. So I'm going to add 4n to both sides. So I get m equals 4n plus 6. So now I have isolated the variable. So now what I do is I'm going to substitute that expression into the other equation. So I'm going to substitute into other equation. And this is why we call it the substitution method. Okay? Okay. So I am going to replace m with 4n plus 6. So 3n plus 5 times a quantity of 4n plus 6 is equal to 7. Fantastic. We have now substituted m into the equation, so you'll notice now in this third equation I've written, there's only one variable now. It's an n and an n, and we can solve this. So of course then that would be our last step. Not last, I'm sorry, don't get too excited. So now what we are going to do is we are going to solve the third equation. Solve the third equation. Okay. Now using our properties of equality, first we'll do the distributive property. So 3n plus 20n plus 30 is equal to 7. Combine like terms. So, whoa, 5 times 6. Wait, 5 times 4n. Oh, yeah, that's right. So now I combine like terms, so I get 23n plus 30 equals 7. I'm going to subtract 30 from both sides. So 23n equals negative 23. And now I'll divide by 23. So n equals negative 1. Woohoo! I found one of the solutions. Now it's time to find the other. Now I have a choice again to make. Choices are great. And I get to decide, do I want to place this n equals 1? Do I want to place it into this equation here, or this equation here? They're all part of the problem. Well, this one looks the simplest to me, so that's what I'm going to do. Okay? So we're going to substitute, again, the substitution method, substitute the value into an equation. Again, you can pick any of them, but pick easy, right, folks? Right. Okay, give myself some space here. So I'll use a different color. So negative 1 is going to go back into one of the original equations. I need to see the original equations. Okay. So it's, how about if I go, m equals 4 times negative 1 plus 6. So m will equal negative 4 plus 6. M is equal to 2. Woohoo! I now have the solution. But before I'm done, I must check, because these values should make both equations true. So over here I'm going to do my check, and so, okay, woo, I had a little mental breakdown. So now I'm going to replace n with negative 1 and replace m with 2, and we're going to see if this works. So I get negative 3 plus 10, yes, 7 equals 7. Now we can't stop because we got to check the second equation. So m, which is 2, minus 4 times n, which is negative 1, is supposed to equal 6. 2 plus 4 equals 6. Yes, I am now done. Please don't stop. Okay, now I'll go back to